Hey, Ag Teacher Thoughts here, coming at you with another video. Well, it's that time of year again. The frost is upon us. The snow is going to fly soon, and winter is here. But the problem we have is we have a small greenhouse that we've got to keep warm. Now, up until this point, I've been using a small electric space heater. Unfortunately, it's not able to maintain the temperatures that I would really like to see while it's running intermittently. So I need to find a way to provide a base heat to the greenhouse, something that I can rely on, that once I set it, I know it's always running and it's providing that heat, something that might even work without power, without, if we get a power outage, how can I keep that greenhouse warmer? And some of you may have seen the short that I released the other day about pranking the HVAC tech, because he was going to come in for a gas leak that we had. So to answer your question, no, I did not prank the gas tech because I like a warm house and I don't have enough firewood to keep it warm this winter. So I didn't prank him, but when he was here, it got me thinking about ways that I could heat my greenhouse. So I started looking, I'm like, hey, are there any small propane heaters that would work for my greenhouse? Unfortunately, the answer is no. And that's because there's a few special things that I need on a greenhouse. One is I need something that's vented. I need those exhaust gases to actually leave the greenhouse. I know a lot of you are going to say, hey, put a catalytic heater in there. Yeah, we can't really do that. It's a fairly well sealed area. There's not a lot of gas exchange. And propane and natural gas, if you get those particles in the air, they can actually interact with the plants. I had an experience when I was younger where I had a whole bunch of perennial fuchsias in a greenhouse and we used a propane blast heater. About a week after we had the blast heater in there, all of the leaves fell off of my fuchsias, which made me think I had completely killed all of them. Luckily, that wasn't the case, but I know that after doing a little research from that, as little as, a few thousand parts per million in a greenhouse can actually cause plants to defoliate. And I don't want to do that because everything that we have in that greenhouse is for next year and for our continued research. The other thing is the huge risk about carbon monoxide, and I don't want to die in my greenhouse. I learned to walk in a greenhouse. I do not want to die in a greenhouse. So it did get me to thinking about gas systems and looking for vented gas systems. There are some that I could look at, but they are thousands of dollars. And we're on a budget right now, so we're not going to do that. So we're going to try to MacGyver something together. And I was thinking, I was like, what types of heaters do I have that run off of propane or natural gas that I can use here at my home? And one of the things that I got to thinking about was these gas torches. And they're really, in essence, they're like a single burner gas heater, because when you look into a commercial heater, it's just a whole bunch of these flames all lined up. Why can't we use just one flame and direct it through a combustion chamber and heat the greenhouse that way? So I gathered a few things for supplies for experiments today, and we're going to try to figure out whether or not that's something we can do. And yeah, I'm going to try to build in some safety systems. I'm aware about thermocouples and automatic gas valves. We'll work into that if I find that this system's going to go, but I'm not going to go spend hundreds of dollars to buy all the supplies I need if the proof of concept doesn't work. So today we're going to look at a couple of proofs of concept. So I do have some MAP gas here. I do like that because of this style of burner or torch head. And then I've got some regular camp propane with kind of standard propane torch nozzle. So I have used both of these interchangeably with propane, so we're going to use them. One flame, I think this torch head gets a little hotter. This one is not as hot, but we'll see what works. So let's bring you in close. I'll kind of show you the setup, and we'll figure out what we can do. I do have some tools that we're going to use. I've got, of course, the two torches. I've got a 5-foot section of copper pipe. I think this is 3/4 inch. Yeah, this is 3/4 inch copper. I've got some bricks set up here where we're going to put our torch body in here. We're going to aim it down the tube, and then we're going to test the temperature down the length of the tube to see if we can find one that works the best. Let's give you a close-up of those torch heads. those are the two different torch heads that we're going to be using. All right, so I'm just going to kind of rest it in there. And my goal is to try to get this to where it simply goes down the pipe and rests well. I'm going to move this a little bit closer. I'll worry about aiming it later, but I do want that torch body inside of the pipe. Okay, let me do some adjustments. Okay, I'm going to take an ambient temperature using my IR thermometer. Looks like it topped out at 85 degrees, 85.8. Okay, we're going to go ahead and aim this like that. Okay, it's going to sit something like that. Again, we are just doing a proof of concept. All right, I'm going to go ahead and light it, and then we'll move the tube in. I think we're going to leave it just out of the tube. We're going to start checking some of the temperature. That sticker is already starting to heat up. It says 102. Probably well over the 203 that it's saying. You know what, let's move this a little bit further. All right, you can kind of see the color change there. And it is creeping down. It is creeping down the tube. And I can feel a bit of radiant heat coming off of that. But what we are concerned about is whether or not the radiant heat is all the way down at the end. Let's try our IR thermometer again. Yeah, I don't think this is going to be able to pick it up. I need a different type of thermometer. So we're just going to have to do the hand method. So I do feel that there's a lot of heat coming off of this here. I can see the discoloration all the way down here, and copper is a really good conductor, so I expect that heat to be quite a ways down. Okay, let's go down here a little bit further. So we're about 2.5 feet down our 5-foot tube. There is some heat. It's uncomfortable to touch, but it's not so hot that it's burning me. So we do have some radiant heat coming off here. What about down at the end on this torch? I can feel hot gases coming out of the tube down here, which is good, and I can feel it condensing too. So we do have our carbon dioxide and water coming off this end, and there's still a fair amount of heat. So I'm hoping that this is probably about the right length for this. This will actually be venting outside. I think I'm actually going to do a full loop, so the air is going to come in and go out. And I chose copper just because of its conductivity. It may not be the best material for this, but it's at least a proof of concept. So I've got enough heat coming out, I am pretty sure. Yeah, it's warm, it's not uncomfortably hot. I mean, the gases are hotter than anything else.
So this may be a good style for us. Now, the other thing with this system, I am going to be bringing the air in from outside. So it's going to come in from the outside, then go into the flame body, and then exit. I'm going to make it a closed system. So I'm not going to vent any exhaust gases inside of the greenhouse, and I'm not going to take inside air and push it out, because that's just going to draft in and suck in more cold air. We want to make it have a closed system like a regular furnace is. So this is fairly good here. How much it's going to keep the greenhouse warm, I don't know. But it is a longer system. And I think 5 feet is going to be about it for this one. So yeah, feeling the warm air out here, I think this is about the right length. Okay, let's go see how far the discoloration has gone. Yeah, so the discoloration is down. It's about 18 inches now. So it has gone a ways. And I can feel the heat radiating off. Oop. Yeah, it's too hot to touch. Yeah, we're not going to touch that. So definitely this is going to have to be suspended below the bench, and then a fan is going to have to blow over it so that we make sure that we're not heating one specific area underneath the bench, because this will go under a bench. Okay, so let's go ahead and take that out. So that's can't really see it. It's a fairly good flame. It's a fairly good flame coming off of there. So it is going to go through a lot of propane. But I can definitely vary it as I need to. Yeah, maybe about there. Okay, I'll go ahead and turn that one off. All right, so I think it's time for us to put the next one up, which it is actually running MAP gas right now, so it's not quite the same, but we will see how it compares. Actually, we could do this. We will switch it over, and we'll do a fair comparison. We'll see if this gets that. Basically, if it moves this color mark down, we'll know that it's doing a great job. I'm going to take this other torch head off. Okay, swap it out for the MAP gas head. We can move our IR out of the way. It's not working enough where it's doing anything. Okay, we'll go ahead and light our MAP gas. Okay, so our color mark is right here. And we'll see what we've got as far as... Oh yeah, that's much more significant. There's a lot more heat coming out there. Pretty ominous noise. Our discoloration of the copper is actually going down further. You can really feel the heat in through here. Yeah, it's moving a lot further down. Uncomfortably hot. So our discoloration had been here. It's now down here, and I realized I didn't let this pipe cool all the way down to just ambient temperatures. I don't have enough time for it to do that. But I think just seeing how it's allowing that to grow kind of shows that this is definitely a better nozzle to use, a better jet. So yeah, the burner unit's actually going to be outside of the greenhouse, and I'm going to build a housing for that and the gas control valve and the thermocouple. I think I'll put that all together outside, just outside the door, and then I'll run this through the greenhouse, or to do a U in the greenhouse and come back out. Because I definitely don't want to have any exhaust gases going into the greenhouse. May not be the best material because I see a little bit of corrosion or a little bit of oxidation beginning there, and you can kind of see, at least I can see the heat waves coming off the pipe. You can see them all along there. Okay, proof of concept. I think it works. Like a single burner heater.
Well, hey, proof of concept. It works. So I can use these as gas nozzles, as gas jets for a improvised heater. I think it's something that's going to require a bit of work. You know, I see that the length of discoloration on this copper is now double the length it was, so it's going to be pretty hot. But I think it'll be something that I could work with. And again, this is an experimentation channel. You know, other things that I've looked at is radiant heating, just using tubing, running hot water through it. Had thought about doing some sort of a non-pressurized boiler to run hot water through it, use one of these flames basically to heat water, and then run a tube through the greenhouse. That's another option. Those are things that I might do a little later on, like once the full larger greenhouse is done. So that's going to go over in that corner of the property. It's going to be more of an artistic build, something that I spend a bit more time on rather than something that I put together in a couple of weekends. But that one I'm going to work a little bit harder on heating systems for that. Going to have official lines of electricity run. I don't think I'll run a gas line up there, but it is a possibility, something I could do. But anyway, proof of concept. It does work. There's a lot of safety devices that I'm going to need to build in, and yeah, it's not 100% like it should be, but it should work. Anyway, I hope you're enjoying learning like I am. We're going to find other alternative ways. You know, one of the other things I'm going to do is I'm going to go find a big candle. We'll put a candle in there and see how that does, because they say a candle can heat a car. See if a candle can heat a greenhouse that's well sealed. But anyway, hope you're learning, hope you're enjoying, and let's follow this journey together and see if we can find another heating system for our greenhouse. Ag Teacher Thoughts, out.